In this video, I will show you how to calculate square roots. Only some simple primary school math is needed. Here is a square. Its area is 3. What is its side length? If the square of a number is equal to 3, we call this number the square root of 3. How do we calculate this number? Obviously, it is approximately equal to 2. Let's assume it equals 2 plus a small error. Square both sides of the equation. Let's calculate the right side of the equation. Just follow the steps in the video. Plus these two together. Replace y with 2. Ignore x squared, because it is a small number. Let's go back to the beginning. We want to calculate the square root of 3 and estimate that it is approximately equal to 2. Now we have its error. Using this error, we get a more accurate approximation. I prefer the fraction form, which is easier to calculate. Repeating the previous steps, you can get a more accurate approximation. You can repeat this step again to get an even more accurate approximation. Now, do you understand? Let's think more deeply. Back in 1584, a Chinese mathematician calculated the 12th root of 2 to 25 places. As you can see, his name is Zaiyu. Let's go inside and take a look. We can tell from the text that he is a prince. He is the 9th generation grandson of the Chinese emperor Zhu Yuanzhang. At the same time, he is also a musician, and the instrument he plays is the Chinese guqin. The text above says that he is a scientist. He is also an astronomer. The tropical year he calculated for 1554 differed by only 17 seconds from today's calculation. His story ends here. If you were a musician, you would certainly be familiar with this number. Back to the topic. How do we calculate this number? Still the same method. Obviously, it is approximately equal to 1. Just follow the steps in the video. you can repeat this step again to get an even more accurate approximation. Obviously, this kind of calculation is not suitable for manual computation. You need an electronic calculator. In Zaiyu's book, The Essence of Music and Pitch, he calculated the 25-digit precision of 2 circumflex, 1/12. He was using a mechanical calculator, which the ancient Chinese called an abacus. I don't know what algorithm he used, but you can use the algorithm in the video. If you pay close attention, you'll notice that the algorithm in the video is the same as the Newton's iteration method, but it doesn't use any calculus.